Tutorial 4, Part 3, Plastic Deformations. When loadings of materials exceed certain level of stress, like yield strength or elastic limit, it will enter the plastic deformation region, in which it will permanently deform. As it is because the stress can break the bonds between the atoms and atoms, and that's why in the plastic deformation regions, let's say for this picture here, where it applies slightly more addition of stress, as there is already no force, or the force between this atom and this atom, it is very small, and slight addition of stress can largely increase the strain value, and that basically is the plastic deformation, the behavior of the plastic deformation region, which you can see in the curve. Okay, so then what will happen if we release the loadings on the material? New bonds will form between the atoms, and it will actually recover some of the deformation. But again, you can see from the picture here, the material itself is already permanently deformed due to the formation of the new bondings. For the stress and strain curve, the material will recover following the same slope as if it was in the elastic region, which we call it elastic recovery, which is fundamentally from the formation of the new bonds. However, as the x-intercept is not the origin anymore, the material will deform permanently, and because the new yield strength of the deformed material is increased, it is harder and stronger than the original materials, which we call it strain hardening, and it is actually a strengthening mechanism. Find the permanent elongation of a 1 meter bar having the following stress strain curve when first under an axial load of 225 MPa, then release the load. First thing you need to find is the linear region, which is marked by the red curve or the red line. Step 2, we offset it to 225 MPa with a ruler. And by this way, we can find the permanent strain value. And also, we can see that the new linear region for the deformed part is the red line, which is longer than the original linear region, which means that it will produce a higher yield strain value after the deformation. Okay, permanent strain is 0.0026, and permanent elongation is basically 0.006 times 1. 1 is the original length, and the permanent elongation is the 6 mm. Another way is to find the E first. E stands for the elastic modulus, which is a constant. Then calculate the resultant permanent strain, which can be found from the slope of the linear region. And permanent strain value is equal to the strain corresponding to the 225 MPa minus 225 MPa over the E, which the second term represent the elastic recovered strain value in the graph. As using this method, we calculated that E is equal to 75000 MPa, and that's why the permanent strain is equal to 0.009, which is the reading first, the intersection here, and minus the 225 over 75000, and which is this value over the slope here, which is also equal to 0.006. And that's why permanent elongation is still equal to 6 mm by definition.